In this video, I'm going to show you my favorite method for solving proportions. And this method was shown to me several years ago by one of my best friends in this profession, and I haven't stopped using it since, and it's made the world of difference for all three grade levels, 6, 7, 8, in any grade where they're going to have to solve proportions. So the first question I have here is just a proportion word problem, and it says Jacob strode up 24 steps in 12 seconds to reach his apartment on the second floor. How many steps did he climb in 9 seconds? So this method is called tic-tac-toe, but now my kids have started calling it hashtag. So anytime they see a problem where they're going to solve a proportion, the first thing that they do is they draw this tic-tac-toe board. The other thing that I have them do is we color code everything. We match everything up nice and neat. So we're going to compare steps in seconds. So in these first two blanks in my tic-tac-toe, I'm going to add those labels, steps and seconds. So over here, we write the two things we're comparing. And so I have 24 steps here. And then I see that my question is asking me how many steps. And then I do 24 steps in 12 seconds. So 12 seconds is going to be green. And I'm looking for 9 seconds. So it's always nice to color code. It helps your kids keep things straight. So my other two labels that I'm going to put are my original amount. So we put an O for original, and then my new amount. And my new amount is always what I'm looking for. And then this box up here, we leave blank. We don't need that box there. So my original amount is where I've got both amounts given to me. So original steps would be 24. Original seconds would be 12. Those two things go together, 24 steps in 12 seconds. My new amount is what I'm looking for. So I'm looking for the number of steps and then how many steps that I can do in 12 seconds. So to solve tic-tac-toe, we cross multiply and then we divide. And so we would have 9 times 24 divided by 12. And so just for speed here, so we would get 18. So X equals 18. Now for your kids that are going to work this by hand, you can simplify this if you want. You can teach them, how do you get from 12 to 9 like you would a regular proportion. But for me, the tic-tac-toe has always made it where they're organizing the pieces of the word problem in the appropriate places. And so sometimes when we're setting up proportions in fraction form, we mix up. And so sometimes we'd put the 9 with the 24, or we'd put the 12 here and the 24 here. And so tic-tac-toe really helps keep it straight. So another proportion problem that I have says Alexa bought a pack of 12 cookies for $3.50 from the supermarket. How many packs of cookies can she buy for $17.50? So anytime we're comparing two things, I go ahead and have them set up a tic-tac-toe. And then we're comparing cookies and money. So we're going to do cookies in pink so I can buy 12 cookies. And again, I'm looking for how many cookies. So I know whatever I'm looking for is going to be my X. And then $3.50 is my money, and I'm looking for how many cookies I can buy with $17.50. So again, I have an original amount, that's the original comparison, and then the new amount is what I'm looking for. So my original amount is 12 cookies for $3.50. My new cookies is what I'm looking for, and I know that I'm going to spend $17.50. So again, we cross multiply and we divide. So I would have $17.50 times 12 divided by $3.50. And I would get X equals 60. So these are just regular proportion word problems, but there's lots of other problems that you can use these for. So in 8th grade, we do a lot of direct variation. And so again, this is one of those things where I can tell them, if you see the words varies directly with X. So if they see varies directly, they immediately, before they even read the problem, they set up a tic-tac-toe. And so the value of Y is 24 when X equals 8. Find the value of Y when X equals 5. So I've got here, Y is 24. And then my question is find Y. So that's going to be my variable. And then I've got X equals 8 and X equals 5. So the two things that I'm comparing here are X and Y. I have an original amount and I have a new amount. So my original X goes right here. So my original X is 8. My original Y is 24. And then my new X would go here. So that's my 5. And Y is what I'm looking for. So instead of confusing them and putting an X here, with direct variation, we usually put a question mark or we'll put a Y again. So again, cross multiply and divide. And I always tell them you always go diagonal first. So we're doing 24 times 5 divided by 8. And I get my question mark here, or my Y, is going to equal 15. So they will work for all kinds of direct variation problems. And then some other type problems that you might see are scale factors. So scale factors is taught usually in 6th and 7th grade. So again, I teach them if you see scale factor, anything that has to do with scale factor, automatically draw your tic-tac-toe. And so here I'm comparing the scale and the actual distance. All right, so the scale of a map is 2 centimeters, and the distance on a map is 12 centimeters. And so the scale of the map is 2 centimeters equals 4 miles. I want to know if it's 12 centimeters on the map, what would be the actual distance in miles. And so the other way that you can do these scale factor ones too, instead of doing scale and distance, if it's hard for them to tell the difference between scale and distance, you can do the unit of measurement. So here I'm comparing centimeters and miles. So if they give you different measurements, sometimes they don't. They work great in these. So again, I have my original, I have my new. Sometimes we'll write even the scale up here. This is the scale that they give me. So the original amount of centimeters is 2. The original amount of miles is 4. And then the distance on the map is 12 centimeters. So I know centimeters has to go in this row. And then I'm looking for miles. So we cross multiply. And then we divide. So we would have 4 times 12 divided by 2. So I would get X equals 24. And I'm a stickler on this. If it needs to be miles, if it has a unit, I want them to write it for me. So X is going to be 24 miles. So another problem you might see, and this works with, is indirect measurement. So a child 4.5 feet tall cast a 6-foot shadow. A nearby statue cast a 12-foot shadow. What is the height of the statue? So sometimes with these questions, they provide you these nice diagrams. Sometimes they're going to have to draw them for themselves. But again, if you train your kids when they see indirect measurement or they're talking about shadows to do tic-tac-toe, it helps them big time. So the two things I'm comparing here, I'm comparing my child to my statue. Now up here, the labels I'm going to use the height and I'm going to use the shadow. And so if you do have diagrams, these labels really help. So the height of a child is 4.5 feet. The height of the statue is my unknown. The shadow of the child is 6 feet. And the shadow of the statue is 12 feet. So here I would cross multiply and divide. So I would have 12 times 4.5 divided by 6. And I would get x equals 9. Again, I'm a stickler on labels, so the height is going to be 9 feet. All right, and then one final question. This is actually what I taught in my classroom today. We did similar figures. And so with similar figures, there is a lot of color coding that goes into this because they have to match up sides. But after today, my kids know if they see these similar figures and they're looking for one of the side links, and they did this today. Before they even started on the worksheet, they drew a tic-tac-toe for every single problem they had. So the two things I'm comparing here are my triangles. So ABC and DEF. And then we today went ahead and labeled inside the triangles. It just helped them identify. So how we did this, I told them on these, the first thing they need to do is highlight the side with the X, with the variable. So we highlighted EF, and then we went to the name and we rewrote the name bigger, and then we wrote them on top of each other. And so the reason we did this is in the name, I made them highlight the side. So here we highlighted EF. And so I told them if you highlight the last two letters in DEF, you have to highlight the last two letters in triangle ABC. And so immediately they knew which two sides matched up. And so then I told them pick a side where you have a number on both triangles. So here I've got AC. So how we did this, we highlighted A, we highlighted C. So we highlighted the first and the last letter, which means we have to highlight the first and the last letter here. And I tell them it's like connect the dots. So I've got a D and an F, so I have to connect the dots from D to F. And then for our comparison up here, we just made highlighter marks, a pink highlighter mark and a green highlighter mark. And so then we said, okay, I need the pink side of triangle ABC, and they could easily find it. And then the pink side of DEF, that's X. And then the green side of ABC, and that's 12. And then the green side of DEF is 3. And this made a world of difference today. This is the first time I've really taught the labeling this way, and it worked fantastically. So we do cross multiplication, and then we divide. So I would have 3 times 20 divided by 12, which would give me an X value of 5. So I hope you enjoyed this video. Please make sure that you subscribe to my YouTube channel, check me out on Facebook, and please check out my Teachers Pay Teachers store. Thanks for joining me.